Why did the world's two biggest space agencies suddenly go silent right after the object changed direction? New observations and measurements bring Atlas back to the center of scientific attention, not due to rumors or speculation, but because of a concrete sequence of results that demand urgent reevaluation of everything we thought we knew about this interstellar visitor. The most recent post-perihelion images reveal a compact nucleus without the expected massive tail, while precision astrometric measurements indicate lateral displacement and non-gravitational acceleration that continues to challenge our understanding of cometary physics. But here's where things take a dark turn. Sudden administrative changes in space agencies, public reports about strategic dismissals, and growing speculation about political motivations to withhold or release high-resolution images that could change everything. On November 4, 2025, President Donald Trump made an announcement that caught the scientific community by surprise. On his Truth Social network, Trump announced the replacement of Sean Duffy as NASA administrator with billionaire Jared Isaacman. Jared Isaacman isn't just another political appointee. He's the billionaire pilot who's personally flown to space, the first NASA administrator with plans to potentially fly towards the object himself. The timing didn't go unnoticed. Many began commenting that this replacement happened right after a controversial response on Twitter directed at Kim Kardashian. Was this merely a routine administrative change, or is there something deeper at play when it comes to Atlas observations? While everyone awaited the end of the American government shutdown and the release of the best Atlas images captured by the HiRISE camera, something extraordinary happened. And just when scientists thought it was over, China's National Space Administration broke the silence. On October 3, 2025, the Tianwen-1 Mars Orbiter captured images from 28.96 million kilometers away from Atlas. These aren't amateur images. They're professional-quality scientific data from one of the world's most advanced space missions, the Tianwen-1 Orbiter, which entered Mars orbit in February 2021, used its high-resolution imaging camera, HiRIC, equipped with a 38.7 centimeter diameter primary mirror. Although it has lower resolution than the 50 centimeter aperture of the American HiRISE camera, the Chinese images are revolutionary. The released HiRIC images show Atlas's nucleus and a surrounding coma with a diameter of several thousand kilometers. Even more impressive, Chinese researchers generated a complete animation of Atlas's trajectory in the Martian sky based on a series of 30-second exposures that capture the object's movement in real time. Then came the image China wasn't supposed to release. In a surprising turn, an American congresswoman decided to break official silence. On her social network, she published a statement confirming what many suspected. Just had a good conversation with NASA about Atlas. As soon as the government reopens, they will release images and data. Unfortunately, for bureaucratic reasons, this cannot happen until then. Dr. Avi Loeb from Harvard was correct in his initial analysis of the anomalous tail. NASA also observed this. I'm sure this will be one of many interstellar objects we'll be able to track now that technology has advanced. This isn't science fiction, it's data. This statement is explosive for several reasons. First, it officially confirms that NASA observed the same anomalies that Avi Loeb identified. Second, it suggests there are many more anomalous interstellar objects than the public knows. And third, it admits that crucial data is being withheld for bureaucratic reasons. But what happened next shocked everyone. Moments later, the Congresswoman's post vanished. Her account was briefly suspended, citing national security review. But the screenshots had already gone viral. The Atlas mystery isn't contained to Washington and Beijing anymore. European observatories issued emergency coordination alerts. The Indian Space Research Organization confirmed unusual signal interference during Atlas's last pass. Even Elon Musk posted a cryptic tweet, "If it's not a rock, we're not ready." The numbers tell one story, the politics tell another. The numbers don't lie. Models based on the most recent observations reveal two crucial alterations in Atlas's trajectory. 1. Inexplicable lateral displacement. The object showed significant variations in lateral position, left to right, relative to previous predictions. Curiously, there was no appreciable vertical displacement, suggesting a highly specific and controlled movement pattern. 2. Persistent, non-gravitational acceleration. The acceleration signal continues to be present, but with magnitude revised to approximately 1/3 of the initial value published after perihelion. Even reduced, the acceleration maintains statistical significance and remains unexplained by conventional gravitational forces. Technically, this means there are additional acceleration components in the orbital plane, parameters known as A1 and A2, while the perpendicular component A-3 remains compatible with 0. In practical terms, forces act laterally and radially without lifting the object out of the plane in which it moves. Here's where physics becomes impossible to ignore. The standard interpretation of non-gravitational acceleration in comets is simple. Mass ejection creates a rocket effect that modifies the trajectory. Applying conservation of momentum to measured values and assuming typical ejection velocities for cometary gases on the order of hundreds of meters per second, physical estimates indicate that Atlas should have lost a significant fraction of its mass, something on the order of more than 13% during the time of close passage near perihelion. This scale implies the release of billions of tons of dust and gas, material that would form a vast coma, and a tail detectable even by modest observatories. If that's true, then NASA has a bigger problem. The problem is that post-perihelion images don't exhibit this massive cloud. Instead, the nucleus appears compact and the coma is modest. Reducing the estimated acceleration relieves quantitative pressure, less mass loss required, but doesn't qualitatively resolve the fundamental fact: there's non-gravitational acceleration and no cloud-matching classical calculations. Preliminary spectroscopy and comparative analyses reveal traces that defy explanation: nickel predominance with almost complete absence of iron, carbon monoxide to water ratio extremely elevated, signatures compatible with rare volatile compounds, possible byproducts of industrial processing, such as nickel tetracarbonyl. These readings are surprising for a body originating from cold and primitive regions of space, regions that tend to produce objects rich in ice and with typical rocky composition. Optical polarization measurements indicate extreme negative polarization values, interpreted as signals of large, highly porous, and structurally complex particles, completely different from what's observed in typical comets from our solar system. With current elements, only 3 hypotheses remain scientifically viable. If it's a comet, it's rewriting comet physics. Expanded models that contemplate directional ejection, particles that don't form an extensive coma, or ejection at much higher velocities. Adjustments that would preserve a natural origin, albeit exceptional. If it's a machine, it means we're being watched. Non-thermal mechanisms or internal engines, impulse sources that would expel mass at much higher velocities than expected for thermal degassing, drastically reducing the need for large-scale mass loss. And if it's something else, we're in uncharted territory. An artificial probe or artifact requires extraordinary demonstrations: artificial emissions, geometric structure, uncontroversial industrial compositions. Although improbable a priori, the hypothesis cannot be discarded until specific observational tests refute it. Avi Loeb, the Harvard professor once mocked for suggesting Oumuamua could be artificial, is suddenly being proven right again. Here are the 10 observations that cannot be explained away. Number 1. Retrograde trajectory nearly aligned with the ecliptic. Atlas entered the solar system following a retrograde orbit, but surprisingly aligned within a few degrees of the planetary orbital plane. Interstellar objects usually arrive from random directions. This alignment is statistically almost impossible. Number 2. Anti-tail jet directed at the Sun. Images captured the formation of an anti-tail, a beam of dust and gas pointing directly at the Sun. This behavior is opposite to what's established by traditional cometary physics, where solar radiation pushes material back. Number 3. Atypical mass and velocity. Estimates indicate that Atlas's nucleus possesses dimensions above the average for comets, combined with high displacement velocity. This association is extremely rare, and may indicate material more resistant than common ice and dust. Number 4. Synchronized sequence of planetary approaches. Atlas performed a series of coordinated close approaches to major planets, making direct observation from Earth difficult. This orbital dance deliberately reduced the window for collecting the most sensitive data. Number 5. Atypical chemical composition. Spectra revealed unusual nickel predominance, almost complete absence of iron, and high ratio of carbon monoxide to water. This composition suggests origin in astrophysical environments completely different from known ones. Number 6. Extreme negative optical polarization. Measurements indicated negative values more intense than usual for cometary dust, pointing to larger, highly porous particles with complex internal structure not common in comets of local origin. Number 7. Origin direction near the WOW signal, 1977. Trajectory projections indicate approximate origin from the same celestial region as the famous WOW radio signal detected in 1977. The directional coincidence reignited debates about a specific cosmic route. Number 8. Anomalous photometric evolution. Atlas showed sudden brightness increase with strong green emission, visibly altering its coloration. This brightness didn't follow the traditional thermal activity curve, appearing in unexpected peaks. Number 9. Acceleration without matching mass loss. The paradigm suggests acceleration from gaseous material ejection. However, subsequent images didn't show the amount of debris that would justify such impulse, a fundamental physical paradox. Number 10. Constant and symmetric ejection without detectable recoil. Despite fragmentation and gas emission, Atlas maintained apparently uniform and symmetric ejection without showing the recoil expected by Newton's third law. This suggests precisely distributed impulses or extraordinary internal composition. Behind every data point is a scientist who risked their reputation. Dr. Avi Loeb stood alone when he suggested Oumuamua might be artificial. Colleagues dismissed him. Peer reviewers rejected him. Now, every anomaly Atlas displays echoes his original warning. If what we're seeing is correct, Atlas isn't behaving like a comet at all, said Dr. Liu Wen from the CNSA imaging team in a rare public statement before Chinese authorities pulled him from further media contact. And Jared Isaacman, the billionaire pilot now at the helm of NASA, might be the first administrator with plans to fly towards the object himself. The coordinated observation plan between late November and January, with a critical point on December 19, 2025, will be a direct test of all hypotheses. The elements the community seeks to observe are clear. Extensive coma clouds compatible with greater than 10% mass loss. Defined spectroscopic signatures of carbon monoxide, water, nickel, and exotic compounds. Non-thermal emissions, gamma rays, microwaves, indicating unconventional energetic processes. Detailed polarization mapping to characterize particles. High-precision astrometric data to verify maneuvers or variable acceleration. The combination of this data will allow distinguishing between natural massive ejection, high-velocity directional exhaustion, and hypotheses of exotic or artificial origin. On December 19, 2025, the world's telescopes will all point at one spot in the sky. If Atlas changes course again, or if its signal frequency shifts, the debate about intelligent origin will be over. Until then, we wait.